Very good. Well, thank you so much for having me this afternoon. It's great to be here. We really appreciate Dyndrite putting on this event and another great opportunity for our community to get together during these challenging times with the COVID-19 epidemic going on. My name is Winthrop Sheldon. I'm with SLM Solutions. I lead the sales team and the marketing team here in North America. And I'm going to be talking to you today about one of our key value propositions, which is high productivity metal additive manufacturing. I'm going to start with a commercial on our company.
What makes humans so special? What makes us special is our tools. They gave us more strength, more possibilities, and the knowledge to make even more advanced tools. The next tool helps us build the future. Impossible designs, unimaginable constructions, functional masterpieces of metal. A tool that doesn't just build products, but reimagines what is possible. We invented that tool, doubled its power, and doubled it again. And we're not stopping there. For our customers, for the future, for whatever we think of next. SLM Solutions.
Excellent. So I hope the audio came through on the video for you. That video is on our YouTube page if you'd like to see it again. So just a little bit about SLM Solutions. We are an OEM. We build metal printers using selective laser melting technology. This is an image of our new factory built in Lübeck, Germany. We're located in northern Germany near the beautiful city of Hamburg, very close to the North Sea. And our entire operation is run out of this facility. So all of our executive management, all of our back office, all of our production, engineering, R&D, as well as all of our process and material parameter development is done out of this facility. Our business is organized based on a set of subsidiaries that are globally distributed. So I work for the US entity. We also have entities in India, China, and many other areas of the globe. And then the areas where we don't have a direct subsidiary, we operate through distribution partners. So at SLM, we are technology pioneers with regard to selective laser melting or metal powder bed fusion, or DMLS, depending on which term you use for the process. This is the process where you spread a fine layer of metal powder on a substrate plate and melt that layer with a laser. One of the original inventors of the technology is still with our company, Mr. Dieter Schwarze. We're very proud of this. He leads many of our development efforts as we bring the technology forward. We were the first to market with multi-laser machines. This is a core area of our technology and a core area of our productivity. We'll get into that in the talk today. We first launched a twin laser SLM 280 machine in 2011, and we first launched a 4-laser, or commonly known as quad, SLM 500 machine in 2013. So multi-laser is something that we're quite good at. It's something that we have a lot of experience with, and it's something that our customers typically choose from us when they select an SLM machine. Some of the other elements of our technology that push our productivity are our two-directional recoating system, or so-called bidirectional recoating process. This minimizes the time between layers being processed. We have, again, the multi-laser technology, which utilizes our overlap stitching. This is a very unique intellectual IP protected area of our technology, which basically allows multiple lasers to build a single part at one time with homogeneous metal and material properties in between the area where the two lasers meet on the same part. It's a very compelling area of our technology. And then our sintered wall gas flow is another leading element of our technology, which enables clean, continuous gas flow throughout the process of the SLM process. And we're always focused on safety of the process, both with our closed loop powder handling, minimizing and eliminating the human operator's exposure to the metal powder, as well as many other elements like the filters in the machines and other elements of the machine that make it very safe to operate. So just briefly, our product portfolio is focused on the actual machines themselves. So we offer 4 machines today on our lineup that are able to be configured in many different ways. We offer a 5-inch printer, the SLM 125. We offer a 11-inch printer, which is the SLM 280. It's our biggest seller, our mid-size printer. We offer the SLM 500, which is a 20-inch, usually a 4-laser printer. This is a production class printer. And then we also offer the SLM 800, which is an extended Z-height version of the SLM 500 that also has automated on powder unpacking capability as well, that we're starting to ship in the US market. Again, more of a production-oriented printer. One of the unique elements of our printers is that the same optics are available across all the machines. So you can have a 400-watt laser or a 700-watt laser in all sizes of the machine, which enables unique material development and ease of moving material developed on one machine to another in terms of the unique parameters that you would develop. This has helped a lot of our customers develop parameters on smaller format machines and move them forward to our larger production systems. So specifically in this talk, we wanted to focus on high productivity. I think Dyndrite's bringing a lot of technology to the market that's enabling higher productivity and more complexity of geometries, as well as many other benefits to the workflow, the digital workflow related to additive manufacturing. You know, we focus right now on really the hardware elements and the more finite hardware related productivity drivers. So the first one we'll highlight here is laser power. So one of the unique elements of SLM is that we do offer 400-watt and 700-watt laser options on our machines. These are available with the same spot size for the laser. So it's a Gaussian profile, single mode laser. This is unique in that you're able to get much higher power with the 700-watt laser, but not give up the resolution from the fine spot size of the beam. So this slide is talking about the productivity difference in build rate between 400-watt and 700-watt lasers with a fairly generic type of geometry. These they look a little pink on my screen on the green substrate plate of the printer. And this is in the development space in a Magix environment. But these cylinders, you know, they're, again, you wouldn't say they're optimized by any stretch of the imagination for additive, but simply highlighting here a dramatic difference in build rate with the quad laser 400-watt machine, 113 cubic centimeters an hour versus 171 cubic centimeters an hour on a quad 700-watt machine. Again, in aluminum, very fast material to build with, and highlighting the impressive increase in productivity when you increase the laser power. We've been shipping 700-watt laser machines for about 3 years now, so it's a relatively new area of our machines, but it's well tested and well accepted in the industry. Now, the next area that we look at with productivity is the layer thickness that you're effectively able to melt, which enables you to basically proceed through the height of the build faster. Obviously, if you can complete the build faster, you're printing it in less time. So this is a table outlining the layer thickness and the laser power across various parameter sets. So we start on the left side of this table with a 30 micron layer parameter set at 400 watts, and we progress to the right with our highest productivity parameter set, which is the 90 micron layer with using our 700 watt lasers. Obviously, you can see the dramatic increase in the build rate resulting from the use of the 700 watt lasers and the 90 micron layers. I love the image on the right. So this is basically an experiment showing the same geometry being printed in the same, and the printer running for the same amount of time. So you see here 2 components that were printed for 52 hours, but using different parameter sets. So 60 micron layers at 400 watts on the left, and then 90 micron layers at 700 watts on the right. Obviously, the part on the right completed in the 52 hours, whereas the part on the left got about a little bit more than halfway complete. Just expressing very dramatically, the difference in productivity that you gain in the same period of time, printing faster. And so it's a shame, but at some of the trade shows that were canceled in our industry, so the AMUG and Rapid, as well as Aerodef and many others, we will be displaying a full set of these parts that kind of very tangibly paint this picture of the productivity from these different variables that you can have in the machine. And then we move to number of lasers. So more of a hardware related configuration that you can choose with a machine. And typically what we find in the industry is that the incremental cost to add lasers far outweighs the benefits that you get in terms of productivity. So it's when you add a second laser to a machine, it's almost like getting the productivity of a second machine next to the first machine if you're looking at single laser machines. Obviously, from a facility perspective, it's very advantageous to have just a single machine running at twice the speed. So here's a kind of a basic layout of turbine blades. You can see that the single laser SLM 280 machine is going to print about 43 of these components in one build. And the part cost is about $83 out of the build time of 77 hours. You add the second laser, you build the same number of parts because the build plate hasn't changed size, just the optics have doubled. And all of a sudden we go down to 41 hours for that build time, and it drops your price per part down to $53. So again, very compelling. And then if you move up to a production machine, you can almost double the number of components, not quite double, with 78 per build. And your build time is very similar because you're simply doubling the number of optics and doubling the number of parts, very nearly. But you do have a resultant small savings per part. But really the benefit with the production machine is, in the same number of hours, you're obviously doubling your output in terms of parts. You're also enabling yourself to build much bigger geometries, right? So there's parts that you can build on an SLM 500 that you just couldn't build on a 280 due to the build size itself. So very clear benefit of adding lasers, and the industry is supportive of this as well. It's very clear now with many of the other machine OEMs also offering multi-laser systems that this is.
Hey, Winthrop.
Yes.
We've got a couple minutes left, and I wanted to make sure to get one question in. Are you ready for Q&A?
I wanted to play maybe one video that's very short, and then happy to move to Q&A.
Okay, we may not have time for Q&A, but go ahead and play the video.
Okay. So I just wanted to show a live SLM 500 machine with 4 lasers operating. Many folks in the audience are probably familiar with what the process looks like, but I'm always surprised that many people haven't actually seen one of these machines run. So we'll just look at 2 passes of the 4 lasers on the powder bed. That device you see moving is the bidirectional recoder. And now you'll see the lasers fire again for another full layer.
That's slick. All right. Looks like we've got a question from Mike Geyer. Mike, I just unmuted you so you can talk. Oh, Mike?
Yep, I didn't actually have a question. I'm sorry, I'm not sure how that happened.
Oh, no worries. All right. Let's get one from Fabio. Is there a difference on the raw material for use of higher energy to melt the powder?
No, it's the same feedstock powder specification for any of the parameters or any of the laser powers that I've discussed.
All right. Then does the higher cost of multiple laser systems offset the part cost benefit considering the high initial investment?
Yes, in my experience, absolutely. I think the bigger barrier is to make sure you have enough capital in your budget to be able to make the initial expenditure, but the productivity gain is so strong that as long as you can get into a multi-laser system, your productivity on an annual basis will be so much higher that it's usually a very easy business case to make.
All right, that's all the time we have for questions. Thank you, Winthrop and SLM.
Yeah, thanks, Sarah. It's been a pleasure. And thanks to you and Sean and the rest of the team at Dyndrite. It's been great working with you guys. Good luck on the rest of the event.